Look at this geometric problem which is taken from tangent normal. Prove that the locus of the foot of the perpendicular drawn from origin to a tangent to the ellipse x square over a square plus y square over b square equal to 1 is x square plus b square y square equal to x square plus y square whole square. This is the locus of the point of the foot of the perpendiculars which is to be proved. Now at first we draw the diagram. These are two axes. This is x axis, this is y axis, and this is the ellipse. This is the ellipse whose equation is given as this: x square over a square y plus y square over b square equal to 1, and a tangent. At first we draw a tangent to this ellipse at point x1 y1. Suppose this is the tangent, this is the tangent, this is the tangent. Point of contact can be taken as x1 y1, and this is the origin. Origin is O, whose coordinate is 0 0, and from the origin a perpendicular is drawn to the tangent. Suppose the non-perpendicular is this, that is ON. ON is the perpendicular. This N is the foot of the perpendicular. N is the point which is called foot of the perpendicular, whose coordinate is also taken as HK. So we write x1 y1 is the point of contact, is taken as point of contact. HK is taken as foot of the perpendicular. Foot of the perpendicular. Now the equation of tangent at x1 y1 is equation of tangent at x1 y1 is equation of tangent to this ellipse, whose equation is this. This equation of this tangent is x1 over a square plus y1 over b square equal to 1. This is the equation of tangent to this ellipse. This is the equation of tangent at x1 y1 to this ellipse. Now we can also find the equation of perpendicular to this tangent. We can also find the equation of the perpendicular to this tangent, and this perpendicular is drawn from origin. Any line passing through origin can be of the form y equal to mx. Any equation of any line passing through the origin is of the form y equal to mx. M is the gradient of the line. So equation of perpendicular passing through 0 0, that is origin, is of the form y equal to mx. M is the gradient. m is the gradient of this perpendicular. This is the equation. This is the equation of perpendicular passing through origin. This equation is y equal to mx. This is the form of the equation, y equal to mx. Now we have to determine the gradient of this perpendicular to this tangent. At first we shall find the gradient of the tangent at x1 y1. To find the gradient of the tangent at x1 y1, we have to differentiate the equation of ellipse with respect to x. Equation of ellipse is given as this. We can differentiate both sides with respect to x for determining the gradient of this tangent. We have to differentiate this equation with respect to x on both sides to determine the gradient of this tangent. So, after differentiation we get 2x over a square plus 2y over b square dy dx equal to 0. So, dy dx equal to minus b square x over a square y, and also tangent is at x1 y1. So, gradient at x1 y1, gradient at x1 y1, point x1, value of the gradient is this, that is minus b square x1 over a square y1. This is the gradient of tangent. This is the gradient of tangent. This is the gradient of tangent. Now, perpendicular, a line perpendicular to this tangent. So, the gradient of this perpendicular will be negative reciprocal of the gradient of the tangent, because these two lines are mutually perpendicular, that is ON and also NP. The tangent is taken as NP. ON and NP are mutually perpendicular. So, the gradient of ON is the negative reciprocal of the gradient of NP. That is gradient of perpendicular. So, gradient of the perpendicular to this tangent, to the tangent is negative reciprocal of the gradient of the tangent, because tangent and this line, that is perpendicular, are mutually perpendicular, that is gradient and this line, this line is perpendicular to this tangent. So, gradient of the perpendicular is equal to the negative reciprocal of the gradient of the tangent. So, negative reciprocal is this a square y1 over b square x1. This is equal to m. This is equal to m. So, equation of perpendicular. So, equation of perpendicular. So, equation of the perpendicular is y equal to mx. Y equal to mx. M is equal to this. So, a square y1 b square x1 into multiplied by x. This is the equation of the perpendicular to this tangent. Also, this perpendicular passing through the point hk, because n is the coordinate, n is taken as the coordinate of hk. So, also k equal to a square y1 b square x1 multiplied by h, because n coordinate of n is taken as hk. So hk also satisfies this equation of this perpendicular. So we get k equal to a square y1 over b square x1 multiplied by h. Now we have got k equal to a square y1 over b square x1 multiplied by h. Now we have to find out the locus of the foot of the perpendicular, which is n, and its coordinate is taken as hk. So we have to find out the locus of hk. Now the equation of tangent, we have already got the equation of tangent. Equation of tangent is x1 over a square y1 over b square equal to 1. This tangent also passes through the point n, that is foot of the perpendicular. The tangent is passing through the foot of the perpendicular whose coordinate is taken as hk. So hk must satisfy the equation of tangent. So that is hk is on this tangent. hk is on this tangent, so we can write hk also satisfies this equation of tangent, as hk lies on the tangent, as hk lies on the tangent. So hk satisfies the equation of tangent. So we get hx1 over a square ky over b square equal to 1. This is. Now we can also apply this relation in this equation to find out the value of x1 or y1. Now hx1 also here we get y1 equal to b square k x1 over a square h. This is, we can put value of y1 in this relation to find out the value of x1. So hx1 over a square plus k over b square multiplied by y1. Value of y1 is this, that is b square k x1 over a square h equal to 1. Now x1 over a square h plus b square are cancelled out. So k square over h equal to 1. This implies x1 over a equal to ah over h square plus k square. We have got x1 over a equal to ah over h square plus k square. And also we can get the value of y1 by applying the value of x1, that is x1 by a. So y1 equal to b square k over a square h multiplied by x1. Value of x1 is a square h over h square plus k square, that is a square h over h square plus k square. Now a square h are cancelled out, so we get b square k over h square plus k square. So y1 over b, we can write y1 over b equal to bk over h square plus k square. This is now the also the point x1 y1 lies on the ellipse x square over a square plus y square over b square, because y square over b square equal to 1, because x1 y1 is taken as the point of contact, that is tangent touches the ellipse at x1 y1, tangent line touches the ellipse at the point x1 y1. So x1 y1 is obviously lies on the ellipse whose equation is given as this. So x1 y1 must satisfy the equation of ellipse, because x1 y1 lies on the ellipse. So as x1 y1 is the point of contact so this point lies on the ellipse, and this point satisfies the equation of ellipse. So we get x1 square over a square y1 square over b square equal to 1, and we have already got the value of x1 over a and y1 over b. So we can put this value in this relation, and we get x1 over a, that is ah over h square plus k square whole square bk over h square plus k square whole square equal to 1. We have put the value of x1 over a and y1 over b in this relation. The relation is x1 square over b square plus y1 square over b square equal to 1. So we get a square h square plus b square k square equal to h square plus k square whole square. So the locus of the point hk, so the locus of the point hk is a square plus b square y square equal to x square plus y square whole square. This is the locus of the point hk. There are infinitely many points foot of the perpendicular on the ellipse, where infinitely many tangent can be drawn. So this is the representative of these points which satisfies a certain condition. Condition is that from origin a perpendicular is drawn to a tangent at x1 y1, and these tangents are infinite in numbers, and so there we can get infinitely many foot of perpendicular, and this set of foot of perpendicular satisfies this condition, and the locus of this foot of the perpendicular hk is the representative of this, of all these foot of this perpendicular which satisfy a certain condition. So the locus of hk can be written as this, that is a square x square plus b square y square equal to x square plus y square whole square. So, we have derived the locus of the foot of the perpendicular drawn from the origin to a tangent to the ellipse x square over x square plus y square over b square equal to 1.